Welcome back to the fourth part, a very small speed breaker in our journey. Okay, so this part will be basically dealing with one of the small topics, numerically greatest term. Okay, now you will be able to understand what was the difference between highest coefficient and the numerically greatest term. Okay, and nothing else to say. Smaller the part, smaller I'll say. Let's begin with the part. Starting with first the statement and the expansion of x plus y raised to power n, we are looking for numerically greatest term. Okay. Now one thing to note here is that when we did, if you remember in the first early parts, okay, you were noting that the coefficients were increasing. In the middle they were maximum, then again they were decreasing. So when we are talking about middle term, when we talked about the middle term in the last part, the coefficient will be greatest for the middle term. Okay, but if I am looking for numerically greatest term, okay, then I need to consider x and y also. Now again, the general term was NCR, x raised to power n minus r. Now we have discussed when these were variables. Again, if I go for 1 plus x, again not a matter. Why? Because it will depend on x again. Now again the value of x will decide whether that term will be numerically greatest or not. Because if you are talking about the coefficient, we were just limited to this NCR. But when we are talking about numerically greatest term, and if I am saying that okay, at some value of x I am evaluating the maybe this expansion. So which of the term will form the greatest term? Okay, so that is quite of concern that how we are gonna get that. Okay, now obviously in one thing has to be noted that anything goes up goes down. Okay, why? Because these will start decreasing, causing the effect. Okay, now again what is the crux that how we can get this thing? Okay, so numerically greatest term will be the term which is greater than its previous term and which is greater than its next term. If I say tr plus 1 is the greatest term, then it has to be greater than tr and it has to be greater than tr plus 2. Now that is what the logic is and that is what the symmetry says. Okay, and again you will be we will be finding this r based on the x and y values. Okay, so for instance, if I suppose take an example like any random example, I say an expansion is given like this. Okay, I have to find numerically greatest term in this when x at some value, maybe x equal to 2 by 3. Okay, now this is a random example. Okay, now in this what we are going to do, okay, the general term tr plus 1 will be 11cr 7 raised to power 11 minus r minus 5x raised to power r. Now in this thing again note there is 7, there is 5 and there is obviously minus. And again when we are talking about the numerically greatest term, the sign does not matter. Again, the greatest, numerically greatest means we are not going for either this plus 360 or minus 360 x cube or something like that. Numerically greatest term means having the greatest constant part. Okay, so whether I am going for this or plus does not matter. So this won't hinder my thing, but the only thing will be hindrance will be these two things: the highest constant power, because instead of 5, now again one thing, this will be at maximum at middle value, but this will also play a role. Now this will have more pronounced effect than 5y because again there will be many factors, the value of x also. Okay, so what I'm going to do here is this is tr plus 1, so I'll say this is greater than tr plus 2. In r plus 2 it will be r plus 1 and 7 raised to power 11 minus r minus 1, 5x raised to power r plus 1, and this is also greater than 11cr. Okay, tr basically. So in that we will be substituting r as r minus 1. Okay, So this will be r minus 1, 7, r11 minus r plus 1 and 5x raised to power r minus 1. Now again x is given to be 2 by 3. At this stage we will substitute it as 2 by 3. Okay, this also as 2 by 3. Okay, again now here these are just solving the inequalities. You will get some coefficient from this, and I'll solve one for you. Okay, let me use a new one and erase the things here. Yeah, so I'll use maybe this color. Yeah, so first relation will be 11CR 7 raised to power 11 minus r 5x raised to power r is equal to is greater than 11CR plus 1 7r. Now this I can combine here, 10 minus r, this will be 10 by 3 raised to power r plus 1. Now this will again be 10 by 3 raised to power. Now again the terms were looking so cumbersome here, but now as you see I can just bring it here, it will be 7. I can just bring it there, it will be 10 raised to power 3. Now the only thing remains is solving this and this. In this 11 factorial will also get cancelled, so let us solve it here. 11 factorial r factorial 11 minus r factorial. This will be 11 factorial r plus 1 factorial and 11 minus, okay, this will be 11 minus r minus 1 factorial. So again as you can look, 11 will get cancelled. Now this r plus 1 you will bring it here, it will get cancelled with r factorial, so it will remain r plus 1, and this you will take it here, it will be remaining 11 minus r only. So this into 7 is greater than 11 minus r, and rest will be cancelled by this into 10 by 3. Now this is a simple inequality which you can form. Again one thing which I didn't mention in the previous part also, that r should always be a natural or whole number. Why? If you are getting r as negative or you are getting r as fractional, it's not possible. Suppose in the thing which we discussed earlier, the term independent, okay, in that suppose you get something like this, 20 minus 3r is equal to say 6. Okay, now in this case 14 is equal to 3r. Clearly there is no r for this, the value will be 6. So you cannot, you say no term exists of that kind. Similarly here, what you will get here, r is greater than some number, and from this second inequality you will get r is less than some number. Okay, now this will be a fraction, this will be a fraction. Now between these two fractions, whatever possible natural numbers are there, they will form the possible answers. For example, in this case, suppose you're getting r as 3 point something, and suppose this is maybe 4.8. Suppose like this, for example. Okay, now after solving, I don't know what you will get, but okay, for example, you get like this. Okay, so obviously r will be greater than this, r is less than this. Now what does this mean? R is a number which between these two. Okay, and in between these two, if there are one, that is one numerically greatest term. If there are two, means both the terms are having numerically same value. Again, this concept not very important, numerically greatest term, but it can be asked in JEE mains obviously, but less weightage of this topic. The topics coming after this will have significant weightage, but what was the purpose of this? Again, to demonstrate that how we are going to compare the powers and how does these things get cancelled easily. Okay, the main purpose of this part was only to show the calculations, that how we are going to make the calculations easier. Okay, so practice some questions still here on whatever we have done. Once you feel that your base is strong, you are able to find middle term, you are able to do independent of x, you are able to find some powers of x, then only start with the next part. Otherwise, go with the theory, go with some, again revise the things, practice some questions from whatever source you are having, or maybe from the test paper itself. Please do that and then only continue after this part, okay? Otherwise the next parts will seem these parts were here, next parts will be at least this level height, okay? So make sure revise everything. I guess example made it all clear that what was the purpose. So in the next part, our main journey towards IIT will begin. We will be studying the binomial coefficients and their properties, and there you will actually feel the difference, the toughness, okay? So stay tuned for the next part, and please do watch that carefully.